Hello there and welcome back. In this video we're looking at practice 35 on number patterns. Each of these word problems has a different pattern that we need to figure out and work with. I'm going to teach you a strategy here. It's called an input-output table that you will use later on in advanced algebra when you study functions. So this is a good video. This one may be a little bit long, but there are lots of good math skills to be had in this video. So if you turn with me to page 26 in your TABE Tutor Practice Math book, and you may use a calculator on this one, so have your calculator handy, and I will do the same. I'm getting mine ready to go. Let's take a look at number 1. Now in the lesson video, I showed you two famous number patterns, Pascal's triangle and the Fibonacci sequence. So those were pretty advanced number patterns. These are not quite as advanced, but they are in word problems, and so that makes a difference. These are not easy problems. So don't feel bad if these are a little bit tough or a lot tough. Some people will see these patterns immediately and some people don't. So if you don't, that doesn't mean anything's wrong with you. It just means that your brain is not a pattern thinker. But let's see if we can do these anyway. I will show you the input-output table, and I think that will help. Number 1. Emily creates a pattern by multiplying by 3 and subtracting 1. The pattern starts at number 2. What is the fourth number in the pattern? Well, there are 3 key pieces of information here that I want to notice. First of all is the rule. Multiply by 3 and subtract 1. That's called the rule. The second piece of information is that the pattern starts at number 2. And the third piece is actually the question, what is the fourth number in the pattern? So to show you how I would solve this problem, let's start with a box. Just draw yourself a box like that. Doesn't have to be perfect, just sketch yourself a box. The question here is, what is the fourth number in the pattern? So I'm looking for the fourth number. I'm going to draw 5 rows. You always figure out the number you need and then add 1 to that. So I need 5 rows. Whoa. I have a new iPad and pencil, so please bear with me here. I am still getting the hang of this with this new iPad. It's wonderful. Some of my family and friends bought me this for Christmas, so it's something I've wanted for a very long time. Okay, so in this table we have 5 rows and 3 columns, and I'm going to name the columns input, rule, and output. And this will always be the 3 pieces. Sometimes there's a 4th column, but in this case, let's just stick to 3 since you're learning how to do this. The rule is what they told me. Multiply by 3 and multiply by 3 and subtract 1. The rule has to be the same for the whole table. That's what makes this work. Later, you will call this rule a function. Instead of a rule, it will be called a function. And let me go ahead and write that for you. But for right now, we're just calling it a rule, and that's okay. Either way is fine. But if I slip up and say function, that's why. I'm used to calling it a function. Okay, the green part that I highlighted, it says the pattern starts at number 2. So the first input will be number 2. So then on my calculator, I'm going to type 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. So if I put 2 in, do the rule, I get 5 out. Then the 5 becomes the second input. 5 times 3 is 15, and 15 take away 1 is 14. The 14 becomes the third input. I am going to use my calculator here. 14 times 3 is 42, minus 1 is 41. And 41 becomes the fourth input. 41 times 3 is 123, minus 1 would be 122. But that is the farthest that I have to go. 41 is the fourth number. So here is the rule. That's the yellow part that I highlighted. Here is the first input. That's where the pattern starts. So you can see the pieces of that word problem in this table. And the answer that I'm looking for, the fourth number, is 41. So go ahead and mark that one as your answer choice. Number 1 is C. Number 2. Tessa creates the following pattern. What is the rule for Tessa's pattern? Well, again, I'm going to make a box for my table. And to get the rows this time, I'm going to count Tessa's numbers. And there's 6 of them. So I need 6 rows for numbers plus 1 for my header. So I need a total of 7. And I can't get these exactly right, so bear with me. The bottom row is always a lot bigger. Actually, I can't stand that, so I'll take off what I don't need here in just a second. Or leave it on there. It doesn't matter. Okay, so we have the input. We have the rule. And we have the output. So let me show you something right here. I want you to look with me at this 5 and 16. You see that right there? That's an input and an output. So here is 5 and 16. Here is another one. Let me mark it for you. 16 and 27. That's an input-output. So 16, 27, 27, 38, 38, 49, 49, 60, and then 60 would be the next input. We don't know the output, though, for 60 because the space after the 60 is blank. It has the dots, the ellipses. So the question here is, what is the rule? We need to figure out what goes right there. How is Tessa getting from the input to the output? So let's take a look here. I can tell you that from 5 to 16, that's building up. So it's either addition or multiplication. And because it's not a big jump from 5 to 16, I'm going to guess that it's addition. So 5 plus something equals 16. What's the difference between 16 and 5? It's 5 plus 11. So let's see if that works here. 16 plus 11 is 27. 27 plus 11 is 38. 38 plus 11 is 49. 49 plus 11 is 60. So the rule here that Tessa did to get this pattern is to add 11 every time. Don't forget about building up and breaking down. That's so important. That gives you a clue as to what's happening in the pattern. If it's breaking down, it's either subtraction or division. So by thinking about building up and breaking down, you can get an idea of your pattern. Now sometimes you have building up and breaking down, like this one. There's building up by 3, breaking down by 1. So sometimes the rule will have both operations in one rule, and that's okay. You can certainly do that. Okay, number 3. Cameron divides a garden into 3-foot by 3-foot squares to create 9 squares. In the first square, he plants 1 spinach seed and uses the rule multiply by 2 to determine how many seeds to plant in the next square. How many spinach seeds will Cameron plant in the 6th square? So let me highlight for you. We know the rule. It's multiply by 2. They tell me that in the first square, he plants 1 spinach seed. And then they want us to find what goes in the 6th square. So here is the table. If we're going to 6 squares, I'm going to make 7 rows. Add 1, that's for your header. So there's 1, 2, 3, 4, 5, 6, 7. And this time, I want you to make 4 columns. And I'll show you why. So here we have an extra column. Because this is a story problem, I'm going to add this extra column and I'm going to call it the squares. And instead of using numbers, I'm going to use words. I don't want these numbers getting mixed up in my problem. And it tells me in the blue there that we're supposed to go down to the 6th square. Okay. Then we have input, rule, and output. Now they told me the rule this time. I don't have to find that. The rule is multiply by 2. And that will be the rule for this whole table. You cannot change rules in the middle of the table. You have to keep the same rule all the way down. And then the other piece of information is the green. It says in the first square, he plants 1 spinach seed. So we have enough here to find our answer. 1 times 2 is 2. Bring that 2 down here. 2 times 2 is 4. Bring the 4 down here. 4 times 2 is 8. Bring the 8 down. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. But we are looking for what is in, that's the input, the 6th square, and that is the 32. So in square 6, according to this pattern, he needs to put 32 seeds. That seems like a lot of seeds for a 3 foot by 3 foot square. But I don't plant spinach, so I don't know. I don't eat spinach either. I like it raw, but not cooked. Number 4. Which 2 numbers are missing from the pattern? So let's build a table. Count the numbers and the blanks. You want to make sure you count the unknowns as well. So there are 6. That means I need 7 rows. This is not a story problem, so I'm just going to make 3 columns. For input, rule, and output. Okay, I know when numbers are side by side, like the 86 and the 79, that's an input-output. So 86 is the input, the output is 79. 79 is right beside 72. But then I come up on a blank space. So I'm not going to fill the rest of this in right now. Let's get our rule and then we'll continue. So from 86 to 79 is breaking down. It's getting smaller. That's either subtraction or division. And it's a small jump from 86 to 79. It's actually a jump of 7. So that's probably subtraction. If it's a big jump, I would look at division first. But since this is not very much of a jump, I'm going to look at subtraction. So let's see if that works. 79 minus 7, that's 72. 72 minus 7 is 65. So that will be this unknown. Then 65 minus 7, sure enough, that's 58. And then 58 minus 7 is 51. And that is the second of the unknowns. So when I go to pick an answer here, I want to choose 2. We have to choose 2 answers. 65 and 51. Okay. You have to pick both of them because the question asks which 2 numbers are missing from the pattern. If you wanted to go ahead and finish this row, you can. I don't like leaving things unfinished. 51 minus 7 is what, 44? But you don't have to do that if you don't want to. We have our answers. All right, number 5. What is the rule for the pattern? So we are looking for the rule. If you want to do the table, you don't have to build this table. This is just one way of showing you how to do it. I do the table whether you guys are with me or not. It's just my habit. 1, 2, 3, 4 entries, so I'm going to make 5 rows. I still got it too big. I've got an extra row down there. Let's do input, rule, and output. This is not a story problem. So input, rule, and output. And these numbers are side by side, so I can count. Here's the input that goes with this output. With this input, I get the 112. With the 112, I get the 28. And then we're supposed to figure out the rule. I don't need this extra row. So we're breaking down. We're going from 1792 down to 448. So I know it's either division or subtraction. And this is a big jump. 1792 all the way down to 448. That is division. I would bet on it. So I divide those two numbers to figure out that I'm dividing 4. 1792 divided by 4 is 448. So let's see if this pattern holds here. 448 divided by 4 is 112. 112 divided by 4 is 28. And then if you want to finish the row, it would be a 7. If the rule doesn't work all the way down, you can't use it. But this one does. It's dividing by 4 all the way. So that one is C. Okay, number 6. This is just a picture pattern, so I'm not going to draw the input-output. It says, what is the next row in the pattern? Well, this one has 3 triangles. This one has 6. This one has 9. So I am building up by 3. So every time I'm adding 3 triangles to the list. So what would it be? 3, 6, 9, 12. Okay, that is A. With the picture pattern, you don't need the table. I don't draw a table with that one. You can if you want, but it's just more, that one you kind of just look at. This one's a tricky one, guys, because of the fractions. But I'm going to show you a trick to deal with this. So don't panic here. It's okay. It says to find the next 3 numbers in the pattern. So we're looking for 1, 2, 3 missing numbers. So if you count those 3 blanks and then the rest of those numbers, that's 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to add 1 to that to get 9 rows for my table. So here's 1, 2, 3, 4, 5, 6, 7, whoa, look at this, 8, 9. And it's not a story problem, so let's do 3 columns. And let's do input, rule, and output. Now, the 1/2 and the 1 1/4 are side by side, so that's an input and an output. I'm going to do 1/2. Notice how I'm lining these up. Leave yourself some space. Then 1 1/4 goes with 2. 2 goes with 2 3/4. Then 2 3/4 goes with 3 1/2. 3 1/2 goes with something we don't know yet. So we have to figure out the rule. And this is a little bit tricky with fractions. Now, if you see it with the fractions, go with it. But if you don't, here's a way that you might want to think about it. I'm going to convert these fractions to decimals. What is 1/2 of $1, of 100? It is 50 cents. What is $1 1/4? That's $1 1/4, 125. $1.25. This is just 2. I'm going to make it money so I can think about it that way. 2.00. $2.75. That's $2.75. $2.75. $3.50. That's $3.50. And then $3.50 here. And we're going to find the rest of these. Just hang with me here. If you need to stop the video and think about what I've just done there, that is fine. Think it through. Think about money. Okay, I know that to get from 50 cents to $1.25, I am building up. So that's addition or multiplying. It's not a big jump, so let's see what addition would get us. 50 cents plus 75 cents would give me the $1.25. So let's see if this works all the way. $1.25 plus 3 more quarters is $2. $2 plus 3 quarters is $2.75. $2.75 plus 75 cents is $3.50. $3.50 plus 75 cents. Use your calculator if you need it. I'm going to go ahead and copy this pattern because I know it has to work for the whole table. That's why this process works, is because we don't change the rules. All right, so where was I? $3.50 plus 75 cents, that's going to be $4.25. We'll come back and get the fractions, but let's just stick with our money for the moment. $4.25 plus 3 quarters is $5. $5 plus 3 quarters is $5.75. And $5.75 plus 75 is going to be $6.50. So I've got my numbers. I just need to convert them back to fractions. 4.25 is 4 1/4. 5 is just 5. And then 5 3/4. If you want to convert them over here, you can. That's 4 1/4, 5, 5 3/4, and then 6.50 would be 6 1/2. So the next 3 numbers after that 3 1/2 are 4 1/4, 5, and 5 3/4. So for this one, I really like answer B. That's a tough one. Just the fact that it's fractions or decimals, it's not even numbers, that makes it harder to do. But on this one, I would much prefer to work with decimals than have to get common denominators and all that. But you certainly can do it with fractions. If you have a job where you use a measuring tape, a construction job, the fraction way would make much more sense to you probably. Decimals make more sense to me, but it's all in what you prefer. Alrighty, number 8. Haley saves money for a new car. She increases, builds up, the amount she saves each week by multiplying the previous week by 1 1/2. There's the rule. She starts with $20 in, there's the first input, her savings account. How much money will Haley add to her account in the 4th week? So we're looking for the 4th input. So we need 5 rows on this one. I am going to add the extra column because this is a story problem. So 4 columns. And Haley is talking about or working with weeks. So there's week 1, week 2, week 3. I've got one too many again. Week 4. That's as far as we need to go. So I'll just knock that off. And then we have input. We have the rule. And we have output. And the rule, they tell me, is times 1.5. So I will be using my calculator on this one. I don't want to have to multiply that by hand. And it says she starts with $20 in her savings account. So that would be the first input. Alrighty, let's go for that calculator. We've got 20 times 1.5. That's going to be 30. 30 times 1.5 is going to be 45. 45 times 1.5 is going to be 67.5. And 67.5, if you want to carry this on out, 1.5 is 101.25. But the question is, what is the number in the 4th week? So that's the input. In the 4th week is 67.50. Okay. I hope that you're getting the hang of these input-output tables. I think that that's going to help you in mathematics later on. And let's take a look at number 9. Which 3 numbers are missing from this pattern? So let's see, I have 1, 2, 3, 4, 5, 6, 7. Remember to count the unknowns. So I want a table with 8. 2, 3, 4, 5, 6, 7, and that's too big, so let me just take it off there. I'll get it at the end. So there's input, rule, and output. Input, rule, which we don't know, we'll have to figure it out, and then the output. So 3 and 9, that's an input and an output. It's building up and it's not a lot, so I'm going to guess 3 times 3. It could be plus 6, but this grows from 3 all the way to 2187. So there has to be some multiplying in there. Even though that first input and output is not big, it grows tremendously. So I'm going to check the multiplying and see if that'll work. Okay. So then the 9 becomes the new input. Let's multiply by 3. That would give me a 27. So that first unknown is the 27. And then 27 times 3, this needs to check out. To get an 81, it does check out. That's a good sign. Then the 81 times 3 is 243. So that is this number. And then 243 times 3, I think it's 729, but let me be sure. When I have to start carrying numbers in my head, I get tripped up. Then the 729 times 3 should give us that last number. If it doesn't, something's wrong. And it does. So 2187 is the final number in the series. So, The third missing number is 729. Got to pick 3 to get this one right. So you've got the 27, the 243, and then the 729. Make sure you read very carefully. That's what I don't do. Which 3 numbers are missing from the sequence. So you have to tell them all 3 to have full credit on this one. Okay, number 10. We're finding the next 3 numbers in the pattern. So draw a table. And I have 1, 2, 3, 4, 5, 6, and we are supposed to find 7, 8, and 9. So I'm going to have to do some scrunching here. There's 3 rows, 4 rows, 5 rows. This is much easier to do if you have notebook paper, but I think that'll work. It's not a story problem, so let's just do 3 columns here for input, rule, and output. And I have a 1 that goes with 3.5. 3.5 goes with 6. 6 with 8.5. 8.5 with 11. 11 with 13.5. And then 13.5, we do not know the output yet, but we will. This is building up, and it's not much. It's not a huge jump, so I'm going to guess that it's addition. 1 plus 2.5 would be 3.5. But let's see. Let's make sure it checks out all the way. 3.5 plus 2.5 is 6. 6 plus 2.5 is 8.5. 8.5 plus 2.5 is 11. 11 plus 2.5 is 13.5. 13.5 plus 2.5 is 16. 16 plus 2.5 is 18.5. And then 18.5 plus 2.5 is 21. So the next 3 numbers after, and I did go far enough, but let me go ahead and put this row in because the 21 will come down here. So after the 13.5, you have 16, 18.5, and 21. So I'm liking option A. You have to get the rule and then use the rule. Number 11. This problem reminds me of my dad. He used to make up things like this for me. And it really, really taught me to think. Rather than just give me an easy answer, he would come up with ways to make me think. And I appreciate that so much. When Warren's grandchildren ask how old he is, he creates a pattern they can use to determine his age. Warren's pattern is to subtract 2 and then multiply by 2. The pattern starts at the number 5. And Warren's age, his age is the 7th number in the pattern. And we're supposed to figure out how old Warren is. So So I'm going to draw a table. This is a story problem, so I'll put that extra column in there. And here's my header. And then I need 7 rows. And I think I have an extra one, but that's okay. So column, input, rule, and output. So I'm going to just use number. That's what they used. So number 1, number 2, number 3, number 4. I didn't have an extra one, did I? 6 and 7. And then we have an input. We have our rule, which they told us is subtract 2 and then multiply 2. And then we have the output. And all of this lovely fun starts at the number 5. Now be careful typing this into a calculator. Your calculator will do what's called the order of operations. We're going to talk about that in a later video. So the calculator is going to get you messed up on this one. What I want you to do is think of it this way. 5 minus 2 is 3, and 3 times 2 is 6. 6 minus 2 is 4, and 4 times 2 is 8. 8 minus 2 is 6, and 6 times 2 is 12. 12 minus 2 is 10, and 10 times 2 is 20. Now, if Warren is a grandfather, we know that he can't be 20 years old. So we're getting there, but we're not there yet. So we have 20, take away 2, that's 18. And then 18 times 2 is 36. 36 take away 2 is 34. And 34 times 2 is 68. 68 minus 2 is 66. Times 2 is 132. Now we know that's too far. Warren can't be 132 years old. But the question says, or tells us, his age is the 7th number in. That's the 7th number input. And so Warren is 68 years old. This is a good example of a pattern, a rule that has both breaking down and building up. This is more complex than some of the ones. Okay. Cecilia eats half of the raisins in a carton each day. Well, there's a rule. Half means divide by 2. There are 256 raisins in the carton on day 1. How many days will it take until Cecilia eats only 2 raisins? So we don't know how many rows we need on this one. That's what we're trying to figure out. So let's draw a table. Sorry, that's pitiful. Use the shape tool to get it straight. And let's put a header row. And I'm just going to sketch some rows so I don't have to stop and do this. I don't know how many I'll need, and if I need to, I can add some down at the bottom. I may need to add some. But let's see what we come up with. So here's 1, 2, 3, 4 columns. These are going to be my days. This will be the input. This will be the rule, which we know is divide by 2. That's what half means. And then this is the output. So I'm just going to list some days. The smallest answer choice we have is 3, so I'll go at least that far. And if I need to, I'll keep adding to that. And it tells me in day 1, that's the input for day 1, there are 256 raisins. So let's divide. 256 divided by 2 is 128. 128 divided by 2 is 64. 64 divided by 2 is 32. So I need to go a little further. The next one is 5, so I'll go there. Then 32 divided by 2 is 16. 16 divided by 2 is 8. So I'm still not there. 8 divided by 2 is 4. Still not there. But 4 divided by 2 is 2. And this is the number, the output in this case is what she's eating. So it says, how many days will it take for her to eat only 2 raisins? And in this case, we are looking for an output. So that is going to be 7 days. Okay, number 13. Which numbers are missing from the pattern? And I have 1, 2, 3, 4, 5 to work with. So I'll make a table with 6 rows. And as usual, I went too far. So we have no story this time. This is just a basic pattern sequence. So input, rule, and output. And we will have to find the rule to be able to complete the table. All right, the 2106 is beside a blank, so I don't know its output. I skip 1, I've got 234. I do know its output is 78. And again, let me remind you how I know that. They're side by side. So input, output. And then that 78, I don't know what it's going to be. We'll have to figure that one out. So I need to get a rule. And in order to get the rule, you need to have the input and the output. That's the only place you can find the rule. So I'm going from 234 down to 78. This is either subtraction or division. And because that's such a big jump, I think it's division. So let's divide those two. And that comes up with 3. So 234 divided by 3 is 78. So let's apply that rule all the way through our table. $21.06 divided by 3 is $7.02. 702 divided by 3 is 234. I like that. That tells me that the 702 fits right in here. Then 234 divided by 3 is 78. 78 divided by 3 is 26. This is a little unusual. 26 divided by 3 is 8.66, repeating. It's okay, don't worry about it. We have what we need here. We need the 702 and the 26. You can absolutely have fractions and decimals in patterns, so don't let that disturb you at all. All right, number 14. Leo creates a pattern by multiplying by 5. There's the rule. The pattern starts at number 1. What is the 5th number in the pattern? So the 5th input is what we're looking for. So let me make a table. And this one is a story problem, so I'll make 6 rows and 4 columns. And Leo is doing just numbers, so I'll put that in that first column. So we have number 1, number 2, number 3, number 4, and number 5. And I can't remember if I told you why I write out the words. I don't want those digits to get mixed up in my problem. So if I put a digit 1 there, I might be tempted to use that. So I always just spell it out, and that way I'm not trying to do math with it. We do know the rule. And we do know that the first number, the pattern starts at a 1. So we can find our outputs. This is building up 1 times 5, then 5 times 5, then 25 times 5. This is called exponential growth. It's growing very quickly. Then 125 times 5, I believe, is 625, but let me be sure. And 625 times 5 is growing even bigger, 3125. But our question is, what is the 5th number in? And that is 625. The 5th input is what we're looking for. Number 15. What is the rule for the pattern? I have 4 numbers, no word problem, so I just need 5 rows on this one. There's my header row, and then 4 input rows. All right. Again, it's not a word problem, so I'll just put 3 columns. Here's input, rule, and output. So I have a 2 and an 8, and then an 8 and a 26, a 26 and an 80, and then an 80 and an unknown. So I'm just going to try the choices they give me. That's the fastest way. It is building up, so I would eliminate any subtraction or division, but there are none. All of these are building up choices. So let's try the times 2. 2 times 2 is not 8. So let's try 2 times 3. Again, that is not 8. So let's try times 2 plus 3. 2 times 2 is 4, plus 3 is 7. That one's close, but that's not it either. So what about 2 times 3, which is 6, plus 2? That's 8. So let's see if this one will work for all of them. 8 times 3 is 24, plus 2 is 26. 26 times 3 is 78, plus 2 is 80. If you want to finish it, we would do 80 times 3, that's 240, plus 2, I believe is 242. Let me just double check that. Yes. So the rule that works for these numbers is D. You multiply by 3 and then you add 2. Number 16. Which numbers are missing from the pattern? So draw a table. I have 1, 2, 3, 4, 5, 6 numbers, counting the unknowns. So I'll make a table with 7 rows. Input, rule, output. $111 is right beside 138, so that is an input-output. That's building up, and it's not a lot. 111 to 138, that's not a very big jump. Let's see what it is. 138 minus 111 is going to be 27. So I think the rule is add 27. But let's see. 138 add 27 is 165. 165 add 27. It better be 192 or I'm in trouble. And it is. Then 192 plus 27 better be 219. If it's not, I'm in trouble, but it is. And then 219 plus 27 is 246. That would become the next input. So the numbers that are missing are the 165 and the 246. And you would have to choose the one answer that gives you both of those. So B is the one you want. Okay. Find the next 3 numbers in the pattern. So I need a table. 1, 2, 3, 4, 5, and we're supposed to find the next 3. So I would go with 8 plus 1 row for the header. I'm going to do 9 rows on this one, or try to. 2. Okay. And then column. I'm going to have input. Rule. Output. 85 and 76 are side by side. So that's input, output. 76, 67. 67, 58. 58, 49. and then they want us to fill in the rest. So this is breaking down. It's either subtraction or division. It's not a big jump, so I'm going to bet on subtraction. I think the pattern is -9. But let's try this and see if that holds true. 76 minus 9 is 67. And 67 minus 9 is 58. And 58 minus 9 is 49. And 49 minus 9 is 40. 40 minus 9 is 31. 31 minus 9 is 22. And 22 minus 9 is 13. So could we have our answer here? 40, 31, and 22. And we do. It's right here. Okay, number 18. Enrique increases the time he spends reading each day by adding 15 minutes to his time from the day before. On the first day, he reads for 15 minutes. How many minutes will Enrique read on the 7th day? So they've given us all we need. They've given us the rule. They've given us the starting point. And they're asking us to go all the way to the 7th day. And I do not have room to draw a table here, so let me go to a clean sheet of paper. So let me sketch this out. And let's make room for 4 columns. This is a story problem. So the lines help me a little bit on this one. I probably will still mess it up though. 5, 6, 7. I did mess it up. I think I've got an extra row, but that's okay. Let's do 1, 2, 3, and 4. So I'm going to call these the days. This will be the input. This will be the rule. And this will be the output. So day 1, 2, we got to go all the way to 7. So I'll take off, we don't need to worry about day 8. Just get rid of that, or you can just leave it if you have it. The rule, let me remember what they said, was add 15 minutes. So that will be the rule for the whole table. And let's get the starting point, which would be the first day he reads for 15. Okay, so here we go. 15 plus 15 is 30. 30 plus 15 is 45. 45 plus 15 is 60. Picture a clock in your head, an analog clock, and you can add these a little bit easier. 60 and 15 is 75. You can also use your calculator to add these. 90. 90 plus 15 is 105. And 105 plus 15 is 120, which is also 2 hours, 120 minutes. Oh, wait, no, I need to check my question. how many minutes will he read on the 7th day? So on the 7th day, he would read this many minutes, 105. Be careful with that. 120 is the input for the 8th day. So always make sure you get the question that they're asking. So on the 7th day, he would do 105 minutes. 120 minutes is not even one of my choices. So I would have seen it once I got there. But pay attention to that. It's so important. Okay, number 19, they want to know the rule for the pattern. And we have 1, 2, 3, 4, 5 inputs. So let me make a table. It's not a word problem, so I don't need the big, huge table. 2, 3, 4, 5, 6. The lines really help, don't they? And then you can just straighten them off. I got it right this time. Okay, so input, output, and then rule in the middle. This is not a story problem, so. And I think the question was what was the rule, so they probably are not going to help me there. So let me get the inputs. I've got 368, 317, and 266. 215 and 164. This is incredibly important that you copy this down right. If you don't, you will get the wrong rule happening. Okay, so 368 goes with 317 and then 266. Build your table and then worry about the rule. It's breaking down. So it's division or subtraction. I think it's subtraction because it's not a huge jump. It's 51 though, but I believe this will work. 317 minus 51 is 266. 266 minus 51 is 215. 215 minus 51 is 164. And then if you wanted to finish that row, you could. This could go on forever. But the rule is what they're after. What is the rule? It is minus 51. You could also try your 4 choices there to see which one fits. That's another way to solve this. So you would try subtracting 42. That wouldn't work, and you just have to try all 4 options. That's absolutely a way to get the answer. Okay, that brings us to the end of this very long lesson. I dread uploading this one. It also let me try out my new iPad. I really enjoy it. In the next lesson, we will be looking at that order of operations thing that I mentioned earlier. So if you're not familiar with order of operations, we will build a memory piece, and then I'll show you how to do those problems. So I will see you soon. I hope you have a really good day. Bye-bye.